Hi, and welcome back to our series of videos from AKCP about our test data center, or as we're calling it, the physical twin. For those of you who've been following along, you'll be aware of what it is we've been building here. So it's a test data center where we're going to be able to use it for R&D, for new innovative cooling technologies, as well as other AKCP products, and as a demo center for everything that we can do. So AKCP, for over 30 years, has been supplying the data center industry with environmental power and security monitoring. And we also have a DCIM software, a data center infrastructure management software that allows us to create a digital twin of your data center using the sensors as the input to that. So what we've created here is a physical twin of the digital twin. So let's go and take a look at what it is we've been building. And for those of you who've been following along, you'll already be familiar with some of what I'm going to show you, but we've had some progress in the recent weeks. We've been installing the water pipes. You can skip forward a little bit. I'm going to show you a 3D animation now of what it is we're building, and then we'll go down and take a look at the actual progress. So what you can see on the screen right now is our 3D representation of the test data center that's under construction. We've got hot aisle containment, cold aisle containment, fan walls. We have a few videos which go into more detail on this, which you can check out the link in the description. In addition to the hot aisle containment with the rooftop heat exchangers, we'll also have in-row AHUs and the fan wall in there. And then in our cold aisle containment area, we have a raised access floor and in-row AHUs also. So here we are in the AKCP test data center, or what we are calling our physical twin. Just to give you an update on the progress in here, you can see there's still work being done. We are at the moment installing all of the water pipes. So the water pipes you saw in the previous video getting delivered. All of the various connections and pipes are here, and we've been working on installing all of those, starting with the 4-inch pipes and then going down to the 2-inch and then the 1-inch pipes. So we have a main 4-inch pipe that distributes the water around the facility, and then that branches off into 2-inch pipes and down to 1-inch pipes, which are the actual supplies to the individual heat exchangers and air handling units. Right now we're also testing as well one of the racks with the heaters, as our heater boxes have all been delivered. So let's go and take a look at those. So these are the heater boxes. This box here is where the heater sits, and then riveted to this is this here, which has the fan mounted at the back, and you can see is shaped like a funnel to channel all of the air through the heater. So it's important when we're doing our load testing that we are properly cooling the heaters and we don't have bypass air. So these funnels basically ensure that all of the cold air that we're sucking in from the cold aisle is going to be channeled through the heater boxes, so we can be sure that we are actually cooling off the amount of heat that we're generating. So these will be riveted together after they go for powder coat, and then they'll be mounted into the rack. So let's go and take a look at the one set that we've already got mounted. So here we are in the hot aisle. I'm going to speak loudly because we've got a lot of fan noise in here. Mounted inside of this rack here, we have the 3 heaters. They're on temporary switches at the moment, but we'll have a panel with all of the switches mounted on there that will be in this one use space that we have at the top of the rack. So each one of these heaters is 9 kilowatts. And it's pretty hot if I stand directly in front of it, because from the other side, we've got the fans pushing all of the air through. So in our previous testing, these heaters were getting red hot, meaning we weren't cooling them sufficiently. But with our new setup, we're able to now get the heaters to not overheat. We're able to push enough air through to keep them at a reasonable temperature. Let's go and take a look at the other side. So on this side here, we've got the 3 fans. The 3 fans are going to a VFD, so we can vary the speed of them. In our final setup, we'll just wire them directly to there, and the VFD will be used on the AHU so we can vary the supply air. But we may also have the VFD here as well, so we can balance things. You can see this is plugged in on our bus bar distribution. So we've got 3 heaters plugged in there. You can see the 3 heaters going to the 3 blue sockets. And then the red socket, which is the 3-phase outlet, is supplying the power to the fans that we've got, which is simulating the server fans, which will be pushing the cold air through those heaters. And this area here will be our cold aisle or our cold room. So we'll flood this area with cold air from the AHU, which will be in this space here. We also have a fan wall. So as well as the AHU, we could also turn on the fan wall and push cold air out here into the room, flooding the room with the cold air. And we've got a high ceiling, so it allows for the hot air to rise out of the hot aisle. This area will be boxed in with a chimney. The hot air will go up to a plenum above us. And then we also have mounted up on the top of this steel structure a bunch of heat exchangers. So we'll also have a setup where we can put cold water directly to those heat exchangers, and we'll be able to cool the air as it leaves the hot aisle. So I've turned off the heaters and fans, so it's a little bit quieter in here now. You might be able to hear me a little better as we explore the water pipes. So you can see there's quite a complex system of pipes that we've got being installed up above here. That's partly because in the facility, we are going to be able to configure this in different ways. So we can send the water to different locations depending on the particular test setup that we're doing. So as I say, this is a physical twin of real-life data centers. And different data centers have different setups, whether it be hot aisle or cold aisle containment, raised access floor, fan walls, in-row AHUs, and so on. So we're building all of those different types of setups. And so we need to be able to send the water to different locations. We also have some innovative cooling ideas that we're going to be testing in here, which potentially could save the data center cooling energy. So that's another reason why we have this rather complex setup. So you can see there are our mainline pipes here, the 2 4-inch pipes, one going back to this yellow filter here. So that's an air and dirt separator, which will have a drain on it. So our main water coming in from outside, from the chiller, the first point of contact is going to be that air and dirt separator. We also have some filters outside, but this will just get rid of any air bubbles that may be in the system and also any dirt that potentially has got through the filter. So the cold water will then flow from there along these 4-inch pipes, and you can see there then it is split off in various locations where it comes off to the actual containment pods. So up above here, you can see we also have an air relief valve. So again, any air bubbles that potentially get through can also be tapped off here. We've positioned them obviously at the highest points because any air bubbles in the system are going to want to work their way back up to the highest points. So air release, and then we have 2 variable valves there, which we're able to mix water. So that's another part of our innovations in our cooling system, is we're bringing water in from either our dry coolers or the wastewater from the building cooling system, which still has enough cooling energy left in it to still be utilized here in the data center. Using very efficient heat exchangers, we're able to run the data center with slightly hotter water than what you would normally. So this allows us to do that, and we've got a series of valves there which allows us to mix and feed water back and reduce the amount of water that we're actually using. And that taps off and comes either to the in-row AHUs, which will be located here, or to the overhead heat exchangers there. The water then continues along this path, and we have a return, hot water return, which is on this side here. So this would be our hot water return pipe, which sends water back to the outside to the chiller. And then we have our cold water supply pipe, which comes through to here. Now in this location, we have a cold aisle containment again. And what we will have here is a raised access floor. And so we're going to be sending the cold air from a perimeter cooler under the floor and through perforated tiles into the cold aisle. The water then continues along and goes to a second containment pod here, which is a cold aisle containment with traditional in-row air handling units. This is our water piping diagram here that our contractor's following. So you can see it's pretty complex network that we've got here of various pipes and valves, and then of course sensors. So we have tap-off points that you can see along some of the pipes where we're coming out, and we can screw in either pressure or temperature sensors so we can monitor the whole cooling system. So we're probably about another 2 to 3 weeks away from completing all of this pipe work on the interior, and then we do have some pipe work still to do outside. So let's go and take a look there. So under the tarpaulin here is our chiller that will be generating the cold water for the system. And here we have 2 self-cleaning filters. So the reason we've gone for 2 is 1, to have redundancy, and 2, to do with flow rates. So if we need a higher flow rate, these obviously are providing a constriction. So we're able to run them in parallel together and still get a higher enough flow rate through the filters. But it also allows us to have redundancy. If we need to clean one of the filters, if one of them's out of action, we can actually shut off one side and run the whole system through the one filter. Now they are self-cleaning filters. They have a system built into them where they will purge and scrub the filter clean and purge that water out through a drain. These will be mounted on a frame which will be elevated because the actual inlet is on the bottom, and then the out is coming out of the side here. And then what we have coming out of this flange is the drain when it purges the water. They have Modbus, so we're going to be able to monitor them from the AKCP system to see their status. We'll also have differential pressure, so we'll monitor the pressure on the in and the out of there, so we can monitor the pressure drop. And if we see the pressure drop increasing, then we know that the filter needs cleaning, and possibly the automatic cleaning isn't functioning properly. So this will be connected then up to 4-inch pipe, which will run down here and into the building and go to the data hall that we were just looking at. So at the same time as building our physical twin test data center, we've also been working on expanding AKCP's production capabilities. So I'll just give you a little insight into what we've got going on here. So through here we have our sheet metal laser machine, if you want to come on through. So this is not yet turned on. In another couple of weeks, we will have the engineer from the company who supplied the machine coming in to help get it set up. So all of the parts are still here, crated up, and this is the bed. So in here, we're going to be able to run sheet metal fabrications where we cut 2-dimensional sheets, and then we can take them to the press brake where we can bend them into form. We also have extruded aluminum channels that we also cut, which are used for, say, the SPX Plus product lines. So this hopefully will be coming online in the next month. Going through here then, we've expanded our machine shop area. So let's go and take a look at that. So this is our machine shop where we do milling and cutting of metal and plastic. So a lot of the AKCP sensors, they come in a plastic box, and we have to cut out from their openings for the various LEDs or RJ45 connectors. So in order to make production more efficient, we have some common boxes that we use for several different sensors, but each sensor has slightly different hole configurations. So that's done in here. We also have a small laser marking machine, which is over in the left there. And that is used to mark the rear of the SPX channels with the MAC ID and serial numbers and so on. So that's also can cut out plastic acrylic sheets. So we do use it as well for fabricating some jigs that we use in production. So this area is already operational. The laser should be coming on in another couple of weeks. And next week, we're going to be starting up our press brake and insertion machine. So let's go and take a look at that. So some of you who've been following along with our videos will have seen the video of this being delivered and also the laser. So this was pretty difficult to maneuver into place and get in here. But this is our press brake. So it's very front heavy. It's difficult to maneuver. It wants to always tip over. Basically, this will bend sheet metal. So this press here will raise, you put the sheet metal in, it comes down, and it will bend the metal to a desired angle and radius depending on the type of die that's been used. So we use this for fabricating parts that have come off of the laser. So for example, the 1U rack mount brackets would be laser cut as a flat piece and then put into here where they're then bent into shape. And now for some of the products, we also need to do insertion. Which means that we need to put in a rivet or a standoff that we can screw to. And for that, we have this hydraulic press over here. So this again will be coming online in another week. And basically, you place the piece in here with an insert, and it's a pneumatic riveting. So we have an air compressor there that will power this, and it comes down, and it will rivet the insert into place. So this is all as part of an effort in order for us to make our metalwork fabrications more efficient, faster, and allows us to do quicker turnaround of customized products. So forgive me, I am sweating quite a lot. We don't have our air conditioning working in here yet, and it's over 30 degrees. So it's pretty hot in here, but it's not going to be like that when we start operations. We'll have cooling. Obviously, people cannot work in this environment. We'll probably utilize some of the cooling from the test data center and maybe bring some ductwork into here and pump some of the cold air into here that's coming from our data center there. So for the press brake, we have a barrel of oil here. So this is a hydraulic oil. So this press brake works on hydraulics, whereas the insertion machine is pneumatic. So this will be filled into, there's a large tank at the back here of the press. And then there is a hydraulic pump, which will pump this fluid around to the pistons which operate the press brake. So thanks very much for tuning in. I hope you found this video informative and are keeping up with the progress that we've got here. Don't forget to like and subscribe so you can be kept up to date with all of the latest from AKCP. And I'm hopeful that within the next month, we should be able to start bringing some of our systems in the physical twin online. And we've also got some exciting partnerships that we're going to be working on, where some other companies are going to be bringing in their products to actually test and develop within our physical twin, because getting access to a real live working data center is very difficult. No one wants you to just go in and experiment with your products. So got some exciting stuff that's going to be coming up. Please do keep following along, and I'll see you in our next video.